everyone. I'm Fatima-ezzahra from the Laboratory of Mechanics, Engineering and Innovation at Lansing of Casablanca, and I'm going to present to you today a brief review entitled How Might Hybrid Polymer Composites based on carbon and natural fibers boost the mechanical properties? So, carbon fibers have been preferred for their remarkable characteristics that could be employed in the design of advanced materials. But the high cost continues to be a significant impediment in the industrial market. In this regard, extensive research has been conducted to extend synthetic fibers as carbon with their natural counterparts. In fact, natural fibers offer many advantages, including low cost, biodegradability, renewability. Nevertheless, their hygroscopic behavior results in a poor adhesion and dimensional instability. This had led researchers to make the most of natural synthetic reinforcements without jeopardizing high performance and while achieving significant cost savings and lessening the environmental impact. In today's agenda, the focus will be wholly on carbon fibers, the properties of carbon natural fiber reinforced hybrid composites are presented, and finally, some manufacturing type processes used for the carbon natural composites were discussed. But first, let's start with the introduction. Aviation's history has been completely changed when the Wright brothers took the world's first successful flight by adopting composite materials for the aircraft structure as their first attempt in the 1903. But despite the fact that carbon fiber reinforced polymer composites was first reported in the 1960s, their use in structural applications did not begin until the 1980s. But since then, carbon fiber reinforced composite materials have been applied in numerous ingenious technologies, which makes carbon fibers even more attractive compared to traditional materials due to the high load carrying capacity, the high strength, the long battery life, and of course the low density. A comparative analysis between four different laminates using two different epoxy resins with different carbon fabric styles like the plain wave and the edge harness system. And these samples were subjected to the tensile test. So, according to the findings, the tensile strength results were found to meet aerospace industry qualification and compliance aerospace requirements. However, the cost of carbon remains a major obstacle that limits its use. It was found that short carbon fibers reinforced composites are highly recommended to make low-cost commercial parts. Researchers have been exploring through the years other ways to reduce the cost by the date of implementing carbon with different types of fibers, either natural or synthetic fibers, to assess the impact of different parameters such as fiber content, water absorption, or mechanical properties. But first, what do we mean by hybrid composites? Hybrid composites are the combination of two or more reinforced elements in a single matrix, or a mixture of different matrices with a single reinforcement element, and these hybrids can be made by synthetic fibers, natural fibers, or both. For the hybridization of carbon with synthetic fibers, several experiments have been done on this area. For example, Sung has evaluated the pairing effect of carbon aramid and carbon glass for different stacking sequences and their tensile and structural strength, and it was found that the dominance of carbon affected the tensile strength of both carbon aramid and carbon glass hybrids, which generated a remarkable increase when compared with pure glass and pure aramid. In another study, they have prepared hybrid composites consisting of glass and carbon reinforced with the epoxy and using this time the hand layup method. And the samples were subjected to the bending test. So, among the results found that when the carbon layers are all put in a compression part, the behavior of glass carbon hybrid is similar to the pure glass composite where the progressive failure took place. And this combination is of course useful for applications where sudden failure is to be avoided. On the other hand, for applications requiring high stiffness and low cost, the placement of carbon layers in both ends remains the best combination. In this research work, they have explored the contribution of aramid on the four laminates to evaluate tensile properties under catastatic and intermediate strain rates. It was found that the tensile strength of all hybrid composites improved with high strength. At the tensile strength of a hybrid composites with carbon layers are less sensitive to strain rate. However, the glass aramid had a greater increase in tensile strength and elastic modulus with increase in the strain rate, so suggesting that it can be attributed to the high strain rate sensitivity of glass. Now let's move to the carbon natural fibers. So, natural fibers can be classified into three categories like animal, mineral, and plant fibers. The focus in this presentation will be on plant fibers or the so-called cellulose cellulose fibers. These natural fibers are mainly composed of cellulose, hemicellulose, pectin, lignin, and some other extractives. The chemical composition relies on the fiber source as shown in the table, like abaca, bamboo, banana, cotton, flax, hemp, and it varies with different types, even if they are from the same family or type. Each fiber has a complex structure consisting of a thin primary wall, which is the first layer depositing during cell growth. The secondary wall is made of three layers, and the thick middle layer determines the mechanical properties of the fiber. And despite the improved properties of natural fibers, their mechanical strength cannot utterly replace synthetic fiber reinforced composites in applications which impose high load carrying capacity. In this regard, several studies have been conducted to make the most of natural and carbon fibers through hybridization to meet industry demand with a small environmental footprint. For example, in this study, they have investigated the development of flax-based carbon fiber reinforced epoxy bio-epoxy hybrid composites and their different stacking sequences. And they found out that the results obtained comply that the laminates prepared from epoxy resins exhibit better mechanical properties than the laminates fabricated using bio-epoxy resins. And optimal mechanical properties have been displayed by the C4 consisting of carbon and flax and the epoxy resin. In this research work, they have explored the effect of hybridization of jute glass, jute carbon, with pure jute, and pure glass, and these samples were subjected to the tensile strength test and the Sharpie impact test. So based on the results, it was found that the solution for high tensile strength values is to put high tensile fibers as carbon on the inner layer. On the other hand, the addition of high impact resistant fibers such as glass as outer layers is necessary and crucial to have higher impact values. In this work, which is quite recent, they have investigated the influence of nanofly ash particulate on the hybrid composite made of carbon, banana, jute, and basalt. And they found out that the addition of fly ash fillers has been shown to improve the tensile and structural properties, and the optimal properties have been reported by the combination of 4% fly ash fillers added to the hybrid composite made of basalt, jute, banana, and carbon. So as previously stated, the inclusion of fillers, arrangement of layers, fiber contents affect drastically the mechanical performance of the hybrid composite. But it was found also that the chemical treatment has a huge effect on the resulting composite. For example, the mismatch of the hydrophilic character of natural fibers with the hydrophobic character of a polymer matrix requires a chemical treatment to improve the matrix fiber interface. In this study, they have fabricated a hybrid composite made of coir and carbon, and it was found out a significant difference in mechanical behavior is achieved for untreated core and chemically treated with core fiber. And the same thing goes for the chemically treated core carbon composite, which offers good fiber matrix interface and the fewer polar outs compared to the untreated hybrid core carbon. And this explains the great recourse of scientists to study the effect of chemical treatment based on natural fibers on mechanical properties, as is shown in this table. and it shows that the improved mechanical properties have been improved and enhanced by the use of chemical treatment. Finally, the composite process. So, the manufacturing process of composite materials can be generally classified into open molding and closed molding. Open molding, one of these techniques is the hand layup. So fabrics are laid on a mold and liquid resin is then poured and spread onto the fiber beds by the use of rollers. And this technique is widely used due to its ease of fabrication. The recent traditional molding is, uh, is represented as one of the closed molding techniques. So the preform is then placed into the mold, then the mold is closed and low viscosity resin is pumped into the mold and allowed to moderate pressure through injection ports. Then the curing takes place, and the final step is the removal of the piece. Another technique which is quite different is the vacuum process. So the substitution of closed mold with a plastic bag makes this technique low as compared to two-sided mold. However, this technique is widely used in large applications due to the low cost. So, carbon fibers are represented as one of the promising materials due to its high stiffness, low density, high strength. However, the high cost, in addition to the catastrophic failure generated without sufficient warning, remains one of the limitations that hinders its use. So much academic attention has been drawn to the hybridization of carbon with different types of fibers, especially natural fibers, due to the increase of environmental awareness. As previously stated, the inclusion of carbon in natural fibers results in better mechanical properties. However, the choice of key factors such as fiber content, additional fillers, and even chemical treatment must be chosen with a great precision to get out the best of the combined constituents in the composite product. Thank you for your attention.